Okay, let's dive into this. Welcome to This Explainer. Today we're going to unpack one of the most absolutely vital yet entirely invisible technologies running our modern world. We are unlocking OLTP, which stands for Online Transaction Processing. Look, if you've interacted with the digital world today, you've used it. And right now we're going to see exactly how the whole shebang works.
Think about this for a second. What invisible system is actually powering your daily Amazon purchases, your ATM withdrawals, or even the way you interact with your favorite mobile apps? Because when you click buy or, take cash out of a machine, you expect the system to just know exactly what happened, instantly. The technology making sure those systems run flawlessly without a hitch is exactly what we're exploring today.
So formally speaking, Online Transaction Processing, or OLTP, is a computing system designed to manage and process a massive volume of transaction-oriented applications in real time over a network. Now, I really want you to focus on two key phrases there, real-time and transaction-oriented, right? This isn't about analyzing a bunch of historical data from last year. No, this is about handling the immediate day-to-day operations of a business literally as they happen. Here's our roadmap for today. We'll start with the engine of everyday transactions, look at the core characteristics of OLTP, explain the acid test, break down the three-tier architecture, and finally, look at the journey from OLTP to OLAP.
All right, Section 1, the engine of everyday transactions. Before we get bogged down in the complex architecture, let's ground this in some concrete reality.
A perfect everyday example of an OLTP system is the point-of-sale or POS system at your local supermarket. Think about it. Every single time a barcode is scanned at the checkout, an OLTP system is hard at work. It instantly grabs the product description, updates your total price, and modifies the store's inventory on the back end. It's handling these incredibly short, fast transactions one by one, ensuring the store's operational data is perfectly accurate right down to the millisecond.
Or let's look at a modern AI-integrated example from a ghost kitchen company called Casper's Kitchen. In their setup, when an order is delivered late, an AI agent automatically recommends a refund. But Casper's Kitchen uses a human-in-the-loop system. A human operator actually looks at an internal app, reviews the AI's recommendation, and clicks Apply or Deny. It is honestly fascinating how seamless this is. That single click relies on an OLTP system, often built on something like a serverless Postgres database, to instantly read the data, process that human decision, and write the updated state back into the system in real time.
And this brilliantly illustrates just how ubiquitous these systems really are. Whether you're searching for a product on an e-commerce site and checking out, using your banking app to transfer money to a friend, booking a flight online, or even paying your college tuition fees through a university portal, all of these, absolutely all of them, are day-to-day operations relying on OLTP to generate and record data instantly.
Moving on to Section 2, core characteristics of OLTP. Now, what's really interesting about this next slide is looking at the actual mechanics of how these systems handle the intense pressure.
To manage daily global business, OLTP platforms absolutely must have these defining traits. First, they need extremely high concurrency. Imagine thousands or even millions of users modifying data at the exact same time without the system crashing. It's wild. They also need high throughput to process thousands of transactions per second and nanosecond response times so you aren't left just staring at a spinning loading wheel. And crucially, 24/7 availability. A downed OLTP system literally means lost revenue and furious customers, so reliability is just paramount.
But here's the catch. To achieve that mind-blowing speed, OLTP systems are optimized for very specific, focused tasks. They excel at short, straightforward queries. We're talking about things like inserting a new user, updating an account balance, or deleting a canceled order. They manipulate highly selective, small amounts of data at a time. What they are not built for are complex, analytical queries. You wouldn't use an OLTP system to analyze 5 years of sales data to figure out what discount to offer next month. Doing that kind of massive data crunching would completely bottleneck the real-time transactions of your current customers.
Which brings us to Section 3, the acid test. Because these systems handle our most sensitive data, like our bank accounts and our purchases, they must obey some absolute strict laws.
These are the acid properties, and like I said, they are totally non-negotiable. A is for atomicity, meaning it's all or nothing. The transaction either completely succeeds or entirely fails. C is for consistency. The data strictly follows all database rules and constraints, no exceptions. I is for isolation.
concurrent users won't ever interfere with each other. And finally, D is for durability. Once a transaction is done and acknowledged, it is permanently saved and safe from any crashes or hardware failures.
So, the crucial point is how this actually works in practice. Let's take atomicity. Imagine you're executing a transaction that involves multiple steps, right? Deducting money from your bank, updating the store's inventory, and then generating a receipt. If that digital payment step fails due to a random network error, atomicity ensures the entire transaction is aborted. The inventory isn't updated, the receipt isn't generated. The system reverts back to exactly how it was before you clicked buy. It guarantees your data is never left partially correct. It's just an incredibly elegant form of protection.
All right, let's move to Section 4 and look at the actual blueprint making all this possible, the three-tier architecture.
You can think of an OLTP system as a dynamic, incredibly fast relay race between three main components. First, there's the user interface. This is the front end, like the mobile app or the website you're physically interacting with. Second, when you take an action, your request sprints over to the application server, which could be hosted on-premises or up in the cloud. This server acts as the middleman, processing the actual business logic. Finally, the server hands the baton to the database on the back end, using software like Postgres, Oracle, or SQL Server, and that is where the data is actually stored, retrieved, and modified.
And right at that database tier is where things like isolation and concurrency control happen. Imagine two cashiers at a supermarket trying to scan the absolute last bottle of water in inventory at the exact same millisecond. The OLTP system's concurrency control guarantees that one transaction is going to process first, and the other will have to wait or get a notification that the item is out of stock. There is no way they will both successfully buy that single bottle of water.
Let's move to and see how this builds into our final segment, Section 5, from OLTP to OLApp. Let's see how this fits into the broader world of data.
We've established that OLTP is the original source of data, the fast, day-to-day operations. But businesses also need to step back and analyze all that data to make strategic decisions, right? Well, that is where OLAP, Online Analytical Processing, comes in. Through a process called ETL, or Extract, Transform, Load, the massive amounts of transactional data generated by the OLTP system are routinely extracted and moved into a data warehouse. Once in that OLAP environment, businesses can run those complex historical data queries to discover patterns or calculate profits entirely without slowing down the real-time transactions of their actual customers.
It's truly a fascinating ecosystem. So next time you tap your phone to pay for a coffee or book a flight on your app, ask yourself, how many invisible layers of architecture did your data just sprint through in a single nanosecond? You are interacting with a globally scaled, hyper-fast OLTP system designed to seamlessly manage the real-time heartbeat of the digital world. Thank you for joining me on this explainer. Keep learning, and I'll catch you next time.